Good morning and good afternoon, everyone, and welcome to our January 2023 Midwinter Weather Update. My name is Andrea Berg, and I will be your host. I just want to go over a few housekeeping items before we begin. We are recording today's webinar, and we will share the link to the recording when it's available. So expect an email in about a week or so. If you have any technical difficulties throughout the webinar, just put a note in through the chat feature, and I will take a look and hopefully be able to help you out. If you do have any questions at any point throughout the webinar, please use the Q&A feature on the right-hand side of your screen. And at the end of the presentation, we have reserved time to go over your questions. Today, I am joined by our three hosts, Jeff Johnson, Nathan Hamblin, and Stephen Strum. Jeff is going to start us off today. And Jeff, I'm turning it over to you.
Great. Well, thank you, Andrea, and hello, everybody. Welcome to the midwinter presentation. We're going to look at the balance of the winter. It's always nice to have half the winter over with, and a lot more hope starts to spring as we move toward the end of that rough season for many parts of the country. And I'll be going over a bit of a review of what we've had happen so far this winter. Been kind of chaotic as well as exciting in terms of extreme weather events, but also rather temperate in other areas. Then I'm going to hand it over to Nate, who is our long range lead, the team lead meteorologist, and he's going to go into the mechanics of how we put our forecast together, look at the statistical and modeling data. And then Steve Strum, who is the VP of Extended Forecast Services. He's going to put this all together and give you some impacts as far as what we anticipate will occur for the balance of the winter. And then we'll also have some specific industry impacts at the end, trying to tie that into aviation transportation, as well as the energy sector. So starting out with a review of the winter, the last few months anyway. The highlights so far, this is the third winter in a row that we've had a La Nina, which is somewhat unusual. There aren't too many occurrences of that over the historical record. And generally with a La Nina, we tend to see a more northerly jet stream in northern part of the United States. But this year it has started out being a little bit further south, almost more like an El Nino type setup, where the jet stream comes in to the west coast. It has been coming in south of California into the southern part of the country. We've had one branch that continued eastward through into the southeast part of the country, and then another branch that turned more northeastward toward the western Great Lakes region. So a bit unusual for a La Nina type pattern. Overall, it's been milder in the eastern part of the country, colder in the western half. We have had several brief Arctic air surges that have come down, even starting as early as the month of November. Precipitation has been heavier than average in a good part of the country. We'll see that on some of the graphics coming up. This is in contrast to last winter, which had quite a bit less precipitation over many areas. And then we have had multiple extreme storm events that have occurred in different parts of the country in each of the past 3 months, and we'll go into a little bit of detail on those highlights. We'll be talking, or Nate will be talking a lot about the polar vortex going forward, but just as a quick review, how things have evolved so far this winter. In November, the main polar vortex was displaced off the North Pole, mainly sitting over the North Atlantic, but we did have a little bit of a weaker feature that was in the western part of the country, leading to colder air there. Then for December, kind of a weaker system again, more in Western Canada, the northwest part of the United States. But then late December through the first half of January here, we've had a much more intense polar vortex showing up in the Northeast Pacific, and that has led to some extreme weather along the west coast, as well as much colder conditions, whereas the eastern part of the country has been under more of that high pressure, leading to milder conditions. Speaking of milder conditions, looking at the past 3 month temperature departures for November, the mild weather was over the eastern half of the country, while below normal temperatures encompassed the west. Then in December, we saw a good shot of cold air make its way across the country, mainly around the Christmas week, and that kept really cold temperatures in the northern Rockies, northern plains, and some of that cold did extend into the eastern part of the country, but it was relatively short-lived. And then so far in January, as well as including our forecast for the balance of January, we are seeing generally warm in the eastern half of the country and below normal, mostly confined to the southwestern areas. So looking at the last 2.5 month or 3 month period through the end of January, including the forecast data, pretty much a east-west divide between the west being cold and the east being warm so far this winter. The heating demand, as shown by the heating degree departures, uh, does signify that we have had generally a warmer than average winter. All of the yellow and orange shades represent less heating degree days compared to normal. So from an energy standpoint, even though we've had below normal in the west, the heating demand is pretty close to normal, but it may be a little bit less. Looking at the Great Lakes ice coverage, this is important as we'll be talking about lake effect snows later on. There still is a lot of open water in the Great Lakes. The map on the left shows that we only have 5.7% of the Great Lakes having ice cover on it, which is pretty low. And then all those blue shades on there represent the temperature of the open water. So most of the frozen areas are really confined to bays in the Great Lakes and more shallow areas. So we still have a lot of fuel to put into the atmosphere to produce lake effect snows going forward. The chart on the right shows the ice concentration compared to normal. The black line there in the lower left is the year to date. The record amount of ice coverage would be the red line on there, and then the normal would be the green line. So you can see we're running below normal in terms of ice coverage. Precipitation, as I mentioned, we are seeing a wetter winter so far. Uh, all months, November, December, and January, we see large parts of the country that are experiencing above normal precipitation. The real bullseye that does show up is obviously California has made the news with the extreme precipitation. We'll cover that a little more detail coming up. But we've also seen and expect heavier precipitation more in the southeastern part of the country here through the balance of January. Overall, pretty wet compared to normal, with the exception of southwestern Texas so far this winter. Snowfall, the map on the left shows the year to year or season to date accumulations. The yellow shading represents 1 foot, and then the next level of orange on there would be 2 feet. Then getting up to 4 feet would be the redder shade. So primarily areas where you'd expect it, obviously the mountains in the west, and then the northern plains, upper Mississippi Valley, and the far northern parts of the northeast. But really amounts south of the Great Lakes have been pretty light, and the mid-Atlantic states pretty non-existent in terms of snow so far this winter. Departures from normal on the right, the green shades represent above average snowfall season to date, and the west clearly has had abundant snowfall. The northern Rockies, northern plains, as well as the upper Midwest, but from the Great Lakes area eastward, uh, a lot lower snowfall totals so far. A lot of that is due to the very mild conditions that have been present in the east so far this winter season. Few specifics highlights. I already mentioned it's been milder in the east and colder in the west for the first half of the winter season. But a few of the more notable storms on the period between November 16 and 20, there was a historic lake effect snow event localized in nature that impacted the western and northern parts of New York State. More than 6 feet of snow in some areas where the lake effect snow bands set up, and it was very persistent and dropped those real extreme snowfall totals. Then, about a month later, December 21 to 26, there was a massive storm system uh, that really moved across much of the country, and it brought blizzard conditions and high winds, as well as sharply colder weather, which did impact much of the U.S. as well as southern Canada. And there were 102 fatalities that occurred throughout this storm system from the blizzard conditions and also the cold wave. So pretty impactful, when you compare these to hurricanes, that fatalities generally are nowadays relatively low. 100, more than 100 people dying from a winter storm is pretty significant. 41 of those fatalities were in the Buffalo area, which got hit again with the storm. 56 inches of snow. People were stranded and extreme low visibilities. People just could not see where they were going in cars. You'll remember all the flights canceled, over 18,000 of them canceled due to this storm system, and estimated 5.5 billion in damages so far, so pretty major for a winter storm event, and over 7 million people without power during the storm event due to the high winds as well as the snow. So not a good thing when you have really cold temperatures accompanying it. Those two maps in the upper right show the snow that occurred with it. So primarily the snow was in the north central part of the country and the extreme northern parts of New York State. Then the map to the right of that shows temperature departures from December 23 to 26. So those purple areas, light purple in most of the eastern areas, represent temperatures more than 20 degrees below normal for that 3 to 4 day period. So was a pretty nasty cold snap that did move across the country and interrupted the mild weather that had been occurring. Now moving a little closer to present day, starting December 26th and continuing right up until about now, there was a series of strong to extreme storm systems that developed off the west coast, mainly in response to that polar vortex I showed earlier that has developed in the northeast Pacific. It did bring flooding rains, heavy mountain snows, and also strong winds, some of them up to hurricane force off the coast of Northern California. And this is really what's known as an atmospheric river pattern. We had a very persistent and strong jet stream that was blowing in from the area north of Hawaii and moving all the way through the West Coast region, especially interacting with all of the mountains that are in California and producing real extreme amounts of rain and snow. Uh, the map on the right is just showing rainfall totals from December 26th through January 11th. And much of the Sierras in the purple shades, that does represent rainfall in the 10 to 20 inch range. The white dots or smaller areas would be over 30 inches of rain. Translate that to snow, and it's well over 10 feet. And also a pretty extreme rainfall near the mountains along the coast that did produce significant flash flooding and mudslides. I saw there were over 500 mudslides that need to be cleaned up throughout California with this event. And so far, a total of 20 fatalities with this system. It's kind of hard to estimate the damages, but it looks easily like it'll be over $1 billion. And this has brought up something interesting. There's been a theoretical worst case storm scenario discussed for California called an arc storm, which is an atmospheric river. The K stands for 1 in 1,000 year type rain event. But the last time there was a really major one of these arc storm events was in 1861 and 1862 in the January-February timeframe. And during that period, much of California was just inundated with 10 feet of rain in some spots. San Francisco picked up around 34 inches of rain over about a 40-day period. And there were 4,000 fatalities that occurred with this um, massive event in 1861 and 62. And so there's always been worry that that these events could repeat themselves in a more modern day society. And in fact, there are sediment studies that show there were about 10 such events that have occurred in the last 1800 years or so. So about every 100 or 200 years, these massive flooding events have occurred in California. So how does this one stack up? Well, I mentioned that one in 1861 to 62, San Francisco had uh, 34 inches of rain. So far uh, this year, San Francisco, that map on the right shows their total was up around 13 to 14 inches, and since this map, there have been a few other events that have brought that up, but generally the mid-teens. So just as a rough comparison, this is falls in about half as bad in terms of the amount of precipitation that did occur with that really major event uh, back in 1861. So just something to kind of keep in mind from a historical perspective. This seems like a really extreme event right now, but history says there have been worse ones and likely will be such events going forward in the future. One last thing here, reviewing the weather over the last couple of months. We have had severe weather that's been active as well in December. A number of tornado and severe thunderstorm reports from northern Texas through Louisiana into Mississippi. And then so far in January, the southeastern corner of the country has been active. The red dots represent tornado locations, and the blue indicate severe thunderstorm wind gusts. So uh, pretty pretty numerous activity for the colder part of the year, and we'll be talking later on whether or not we expect the severe weather to continue to be a threat here for later on this winter into the early spring season. So that's a quick rundown on what has happened so far. And now Nate is going to dig in a little bit deeper, see what kind of clues we have that will give us some guidance going forward for the next few months. So Nate, please take it away.
Thank you very much, Jeff. That was great information and a lot going on so far this winter. And we're going to take a little look into if that kind of stuff will continue or if we're going to go a different way. First and foremost, let's take a review of the winter season influencers. Now, ENSO is one of the largest sources of variability in the winter season. 40% potentially, sometimes more, sometimes less, and we have pretty good skill at predicting that. The polar vortex, its movements can certainly influence the season, sometimes as much as 30%, sometimes more, depending upon how bad it behaves. We have fair skill. We have more skill at predicting what types of winters can produce disturbances rather than locating the timing of the individual disturbance themselves. So we'll call that fair skill. Other subseasonal factors, such as the Madden-Julian oscillation, or the MJO, and other things we'll get into a little bit later here. Pretty low skill looking at that from a seasonal standpoint. It's more of a subseasonal thing, something you can identify in the next 2, 3, maybe 4 weeks if you're lucky, and then going forward from there, it's a lot more difficult. So a pretty low skill from a seasonal standpoint, months ahead. And then trends, what's been happening the past 10 years. Is something repeating itself over and over again? We can notice that and build that in. So we have pretty good skill at looking and identifying those trends. As always, let's take a look at the main seasonal drivers. And we've been saying this, as Jeff mentioned, for the past 3 years, La Nina. We've been almost worn out that word, and And we're finally going to be close to the end of it though, because it's going to weaken through the spring season. And I think we have a pretty good shot at saying the El Nino thing that we haven't discussed in quite some time in the summertime. But for the rest of this period through the middle part of spring, La Nina will still be around, although it will be weakening with time. So the sea surface temperature map is the forecast from February through April. And you can still see some blues in that equatorial Pacific region we have labeled La Nina, although you start to see it's weakening. It's not as blue as the ones we've shown you in the past. However, look to the north, there's all kinds of warmth in the north central Pacific Ocean. However, there is still cooler water right along the west coast. So that is the cooler phase of the Pacific Decadal Oscillation, or the PDO. And we have the warm phase of the AMO, which is the Atlantic Multi-Decadal Oscillation. And that is indicative of warmer water in the Atlantic Ocean. So what we like to do from a seasonal standpoint is look through years that had similar ocean temperature profiles, and that can give us some clues as to what might be coming. Let's take a minute and focus on ENSO, and this is through September here from modeling centers all across the world. This is the average temperature in that ENSO area in the tropical Pacific. And right now we are in the La Nina camp here, but every single model you look at, with the exception of one straggler down there, is showing a steady weakening trend or a warming trend. So we're going to go through the ENSO neutral thing in the springtime, and by the time we get to the summer, we have a pretty good chance of getting at least in the weaker end of the El Nino spectrum or the warmer end of the neutral spectrum, which would be a bit different than what we've dealt with here for the past few years. But there's pretty good model agreement on that. So a steady warming trend does appear to be in the cards. So let's take a look at our statistical approach, our analog approach, and this is basically a composite of weather conditions from previous years with similar ocean temperature patterns that we just went over. And looking at sea surface temperature analogs from February through April, we do hit up the highlights with the analog years that we've chosen. Well, we do have the cooler water, although it's not all that cool in the tropical Pacific, and we have the warmth in the north central Pacific with cooler water along the west coast. And we have a lot of warmer water, at least in the northern Atlantic Ocean here. Now, keeping in mind, some of these analogs you looked at the list are pretty old, and water temperatures are cooler than they were cooler then than they are now. So that factors into this to a certain extent. But the idea here is that we have the relative sea surface temperature anomaly pattern covered pretty well. And here are the ENSO trends from our analogs, and right now, the average of that is running a little bit warmer than what we have right now. But by the time you get to the February, it's an April and June period, it fits right in with the trend. So warming up through the spring season and in the summertime on the precipice of El Nino, and we have the spread, I think, covered pretty well. So between the warm end of neutral and the cooler end of the La Nina thing, or El Nino thing, remembering that the average temperature has to be 0.5 degrees Celsius or more above normal to reach that threshold. So let's take a quick look at some jet stream analogs for the next few months. And the faster the wind speeds are, that's usually where the jet stream is, and that's what is represented by the greens and yellows. So a strong jet stream across most of the US here, especially the central to the northeast. So the storm track will be pretty much near where those strong winds are. And then we have a weaker jet stream winds from Mexico to the Gulf of Mexico and near the Gulf Coast of the US. So that is what we have from the analog perspective. More specifically for temperatures, February, there's a lot of blues or below normal temperatures in the central and western part of the country with a focus on the northern plains and into southern Canada. On the east coast, though, the analog suggests warmer conditions will occur, especially east of the Appalachian Mountains and into parts of eastern Canada. And there's kind of a sharp line in between, and usually when you have these sharp lines between the warm and the cold start showing up, so the precip goes along with it, and the analogs certainly bear that out. You can see the greens from the Arklatex region through the middle Mississippi Valley, most of the Midwest, and through the Northeast. So it suggests a very active pattern in that region. A little bit drier near the Gulf Coast, and one thing the analogs are showing is a drier trend across the West Coast, especially Northern California and the Pacific Northwest. Fast forwarding to March, it does show a little bit of a warmer look for more of the country, especially the eastern half. Again, the East Coast is showing the greatest signal, but there'll still be some coolness along across the west, especially the northwestern part of the country. So basically the pattern sort of retrogrades a little bit where everything moves to the west. And for a precipitation outlook, you have the central and southeast US above normal precipitation, a little bit drier in the northeast and the west coast. For April, right when you think you're going to advance into full-blown spring, sometimes it just doesn't work out that way. And the analog suggests that some cooler air will try to linger, especially across the Midwest through the Canadian prairies. And then a little bit milder maybe in eastern Canada through New England, and then again in the southwestern part of the country. The analog suggests this will be a period where the precipitation settles down maybe a little bit, except for across the far northern areas. So from the northern plains to the Great Lakes, and then through the Canadian Maritimes, a little bit more active, but drier across especially the central and southern plains, lower Mississippi Valley, and then through the Appalachians. So we're adding it all up for 3 months here. Warmer along the East Coast, cooler in the West and North Central, and kind of ups and down in between from the Great Lakes through Texas. And February is probably going to play a big part as to why this is going to be an active period, but definitely a wet signal from the Great Lakes back through the Ohio Valley, through the Arklatex region. A little drier along the West Coast and along the Gulf Coast. Snowfall departure analogs. Now, these are the top 6 years here. We have 10 usually, but we figure we'll show the top 6. These are the closest to what we think might happen. And where you see the greens, that means above normal snowfall. And when you see the yellows, that means below normal snowfall. So a lot of greens on the map here, especially across the northwest and north central part of the country. That is it's almost a universal signal, really. So above normal snowfall conditions, that can be inferred in this parts of southern Canada as well. And then you see little greens here and there in the Midwest. 2009 has it, especially 1951. So the Midwest can be added to that, but some of the analogs are a little bit lighter across portions of the Mid-Atlantic, although some aren't. It only takes one storm to really crank up some snow totals compared to normal in those areas. But the idea here is that the Midwest and the northern part of the country will be more favored than the Mid-Atlantic and the Southeast. So let's take a quick minute here to discuss subseasonal influences and the polar vortex strength and location. And as we talked about, that could be a significant influence on the cold season. And I have a few slides ahead to kind of clarify where we're headed in that direction. Tropical thunderstorm clusters of the Madden-Julian oscillation, and that can also produce some changes in the weather pattern, some north-south jet stream fluctuations, which can lead to blocking stall-out jet stream patterns, which can also lead to big changes in temperatures and precipitation patterns. And then the third thing, snow cover and soil moisture. So if you have snow cover on the ground or very nearby, that will promote colder temperatures than if you didn't. And if you have dry soil, you get warmer days and cooler nights. And if you have wet soil, it kind of works the opposite on that front. So let's talk about the polar vortex now. A strong polar vortex is more circular and it keeps cold air bottled up at the higher latitudes. You notice those on the left there, where the strong graphic is, you see the strong, those thick blue arrows there. That's strong winds circulating the polar vortex. And when those winds are strong, vortex is strong, and the cold air is bottled up. However, if you get a weaker polar vortex, those winds tend to weaken a little bit. You get wavy jet stream flows, and little pieces of that can break off and go southward, and colder air is going to follow with it. And wherever those troughs and ridges go will dictate whether you're warm or cold. So just because the polar vortex breaks up doesn't mean your location will necessarily see cold air, but somebody probably will in the mid-latitudes. And the polar vortex is weakest when the zonal winds at 60 degrees north, or basically where that arrow, the set of blue arrows is, when they get near or below zero, that is when you know you have a really weak polar vortex. And the shape of it matters here too. We'll get to that more in just a minute. Prediction time can be limited to under 2 weeks here, as the model guidance tends to struggle with these specific events. They're very complicated things to forecast. So we tend to, that's why they're a little bit difficult from a seasonal standpoint, but when we get a little bit closer, then we can obviously narrow down the impacts. So let's take a look at some model guidance and where we might go. And again, we talked about the zonal winds and ECMWF and the GEFS. First thing I want to say is that we have very strong jet stream winds and a strong polar vortex at the moment. Both models show that, but that's going to change. The last week in January, you see all the model guidance will send the winds in free fall toward below the normal, which is the thick red and thick blue lines. And then there's a lot of spread after that. So you see those blue lines going everywhere. It looks like a third grader drew on the map. So that means there's a lot of spread, and the model guys are saying different things. So there's lots of opportunity here for the polar vortex to become very weak or maintain its strength. A lot of disagreement in the guidance, but the closer to zero that wind gets, the weaker the polar vortex to become. So what you take from this is that there is definitely an opportunity for changes in the weather pattern as a result of this going forward. We talked about orientation and why that matters. Well, let's take a look at kind of what led to the cold that occurred in late December. 500 millibar pattern from the 14th to the 20th of November. Now, first thing you notice here is those oranges in your Scandinavia and Alaska. You have big ridges in those two areas in particular, that can really do a number on the polar vortex. So it wasn't even a week later. Check out what happened. The polar vortex was dropped southward off the pole. It was split actually. Big piece went down across Hudson Bay in Canada, and the other smaller piece went into Central Asia. And you see a couple of ridges just west of Alaska and then across Scandinavia. So that is a classic example of a polar vortex disturbance that would lead to cold air down the road. And obviously you can see how it turned out from the 20th to the 26th, cold across most of the US. And polar vortex, that particular kind of disturbance is exactly the kind you want to see if you want cold air to invade the US. So where are we going to go from here? Well, the GEFS here shows 500 millibars. So again, you can see some ridging in Alaska and ridging in Scandinavia. So you're going to have some pressure on the vortex again towards the end of this month. Those ridges are quite as strong as what occurred there, at least is what the model guidance says now. So the disturbance might not be quite as robust. So we go forward as to what the GEFS is doing at the end of its run on the 1st of February. You can see that the polar vortex, instead of being displaced over Canada, it's displaced over Scandinavia, and there's lots of ridging in that, getting into Alaska and then towards Western North America. So that is a different look. It's not split, and it's not, it's weak, but it's not split apart and set towards our way. So we're going to have a different impact from this, I think. Now, going forward from there, once we see what happens in the next week or two beyond that, if that vortex were to somehow shift across southern Canada, I'd be pretty worried. So about the potential for cold, or just the ridging gets over the top of the pole. Now those are the two types that can bring the coldest patterns into the US. So I think what you take from this is not every polar vortex disturbance will bring in cold into the United States. You need certain configurations. The 10 millibar configurations in the blue boxes from the right there will represent the best chances of cold patterns. So basically the bottom right left-hand one is exactly what happened in November. And the top right-hand or top left-hand one is an example of one that could occur. And if that occurs, that might be more of a problem for Europe, but still has the opportunity to bring cold into the US. So those two are the cold ones. If the other two happen, where it's just displaced and there's ridging, Pacific trough one, that doesn't necessarily bring cold here. So that's one thing. And the other thing we have to worry about is it takes time. So once this stuff happens, and it takes about 2 to 4 weeks for the impacts to reach the US or mid latitudes in general, because it takes time to bring that all the way down to the surface. So any impacts from this disturbance here are probably going to wait till at least late February and early March. So other things are going to take over the pattern between now and then. So enough about the polar vortex. Let's go into the seasonal weather models here before we wrap this up. In the next few months, here is the CFS V2 model in February does look somewhat like the analog to a certain extent. It does have some warmer weather in the southeast, but it's a little bit cooler across the northeast. And again, it shows some of that coolness in the north central and into central Canada. It shows the very same active pattern for the Tennessee Valley, its Arklatex region up towards the northeast, and it's a little more active than the analogs in the northwest. For March, it is cooler all the way around. It's a different pattern, has this warmth in the southwest, cooler in the northeastern quadrant. And it does show active weather across the southeastern quarter, a little bit drier in the west. And then April, it abandons all of that and goes with the warmer pattern, but warmest in the west, coolest in the east. It is a bit of a quieter look, an exception right along the east coast and in the Pacific Northwest. Comparing that to the ECMWF model, February, that's a little bit of a warmer look. So this is probably not going to work out as well, I don't think. But the idea here, warmest in the east and coolest in the northwest probably will. Again, it has that active pattern from the Arklatex region through the northeast, so it's a pretty good signal for that. So spoiler alert, I think that's the way the forecast is going to go. And a little bit drier along the Gulf Coast. For March, it's a little bit warmer, closer to the analogs. Still has some coolness in the northwest and into central Canada. And then precipitation a little bit lighter on the signal. Overall, drier in the southwest and along the southeast coast. And then April, kind of like the analogs, where it brings some cooler air into the Midwest and the central Canada, and a little bit warmer in the southwest and along the Gulf Coast. And then April, it is a little bit wetter in the south, a little drier in the northeast. So a lot of things to consider here. And I'm going to let our closer come in here and tell us how it's going to work out. Mr. Steve, please close the show for us.
All right. Thanks, Nate. Thanks, Jeff, as well for the introductory background information of the year to date, and as well as all the things we're looking at for this upcoming winter season. So we'll kind of combine that climatology, the trends, all the analog and model guidance here, and combine that into our actual forecast here for the balance of the winter season. So looking at a monthly view here, the January map on the top left there is, again, a combination of what we've seen so far to date in January, along with the forecast for the balance of the month. So definitely a very warm looking map there for the eastern U.S. Even if we do see some colder air work in, the extremely warm first half of January is really not going to be able to be erased by any cold that might be coming in later this month. So definitely a warm January. But again, the change is coming in here in the next couple of weeks for a colder regime for the central and western U.S. And that should allow for most of the country from about Chicago to Houston westward to average colder than average during February. The East Coast will likely still see some periods of cold during February. It won't be warm the entire month there, but the warm period should generally be a little bit stronger than the cold periods in terms of the anomalies, and the warm days should outnumber the cold days overall. So behind each storm system, we'll likely see a brief round of colder air move into the East Coast, just not sustained cold for that region. And then as we progress into March, we should see an expansion westward of the warmer anomalies, and the cold will likely retreat farther to the west as well, and kind of focusing across the northwest, and for the most part, most areas across the eastern U.S. trending milder. But we could see one more round of winter weather return to central and eastern areas of the country, at least for a time, during the month of April. Looking at our actual forecast composite for February to April, that's your map there in the top middle. Overall, central western U.S., again, being the areas that should average colder than normal. And most of that is, again, skewed by February being the far and away the coldest of the 3 months in terms of the anomalies. The East Coast, for the most part, averaging warmer than average for most of the next few months. The colder scenario isn't really a whole lot different. Just it's kind of hard to tell, but the cold anomalies are a little bit stronger across the north central U.S., and the West Coast could also be a little bit colder in that scenario as well. Again, the East Coast likely still coming in warmer than average. And then if things transition a little bit faster during February, and we don't see a major polar vortex influence to kind of carry the cold longer into the early part of March, then that faster transition to warmth would likely result in most areas east of the Rockies coming in warmer than average. Either way, our degree day totals in that table there below the map show that we should average warmer than normal for the winter season, including the November to March total, even in that colder scenario. So not really a whole lot of risk here that we're going to come in colder than average for the winter season as a whole, given what we've seen so far. But we may actually come in still just a hair colder than last winter for the entire November to March period. Again, kind of that La Nina-like pattern during the month of February, but transitioning to a warmer regime as we progress through the remainder of the cold season into the early part of the spring. Now, looking a little bit at or into the degree days a little bit more detailed here, we are looking for the top left map to show that we are slightly higher than the last few winters in terms of degree day totals through March. This comes into about a 10th warmest ranking for the entire November to March period, looking at just the last 40 years. So definitely on the warmer than normal side, but a little bit colder than the last few winters overall. Again, the table on the bottom left there shows our December to February, November, March to May, and November to March totals coming in all for the most part right at or below average in terms of HDD totals. So again, on that warmer side of normal, even in our colder scenarios. Looking at the precipitation totals here, most of the country obviously quite wet here during the month of January. As we progress into February, the key areas that we saw the heaviest rains will shift a little bit during February. The northwestern U.S. seeing more rainfall after being fairly dry during January with all the rain focused across California. They should see more rain in mountain snows during the month of February, but Northern California could still stay fairly wet during February. Farther east, the Ohio Valley, Tennessee Valley region should be, again, a focal area like it has been so far for heavier than average precipitation, but Florida could stay drier than average, as could parts of the Southwest and Texas. As we progress into the spring months here, March, again, looking to be wetter than average across a good chunk of the central and eastern U.S., but we should see finally a relaxation in the rainfall pattern across the western U.S., trending drier along the west coast, and that should continue as well into the month of April. Dryness could expand a little bit across the central U.S. during the month of April, but likely staying wetter than average around the Great Lakes and across the Northeast. Kind of summarizing that into the 3-month total, the northwestern U.S. as well as much of the central and eastern U.S. away from the Gulf Coast should come in wetter than average. Now, in terms of snowfall, our snowfall map on the right there shows the northern tier coming in snowier than average for the remainder of the winter season. The western U.S. will be highly variable, but mountain areas from California to Colorado and northward should all come in snowier than average going forward through the end of the winter season. But again, we should see some reduction in the rain and snow there once we get past the first half of March or so, kind of as we head in towards April. The overall trend does look drier there, especially. For the mid-Atlantic, though, we haven't had any snow at all so far this year in New York City and Philadelphia in terms of measurable snowfall. And the pattern does look to stay less snowier than average, with the storm tracks, for the most part, keeping the snowfall away from the immediate coast. Now, we could see still certainly one coastal storm track far enough east where we do see a major snowfall event in the major cities of the East Coast. That could still certainly happen and boost the snowfall totals up closer to average. But for the most part, the vast majority of storm systems should be kind of doing that inside runner track where the areas along and west of the spine of the Appalachians see the bulk of the snowfall during the remainder of the winter season. Now, across the south, snowfall in those areas is highly dependent on whether or not it even snows. So there will likely be areas in the southern half of the country that do see above average snowfall, but it will be highly variable just depending on individual storm tracks and where those happen to go. Now, in terms of drought conditions, obviously we've seen tremendous improvement across the western U.S. But we do actually still have long-term drought in place across most of the region, including California, even though we have had a substantial amount of rainfall and mountain snowfall in the last few weeks. We still have reservoir levels below average in many cases, and the heavy or the extreme intensity of the rainfall caused a lot of the rain to just run right off. And so we didn't actually see necessarily as much recharging of groundwater as you might expect, given the intense duration or intensity of the rainfall and short duration that it all fell in. So there's a lot of runoff. So we still actually have below average groundwater in many areas, at least in terms of the deep water ground or deep level groundwater. And again, reservoirs are still actually running below average, at least for the major reservoirs. The chart on the left shows reservoir levels for California. I kind of highlighted in red there the largest of those reservoirs in California that are actually still running below average. The green lines there all indicate the normal level of water for this time of the year, and the blue bar is indicating the current water level. So many of the major reservoirs are still below average in California, despite the extreme rainfall of the last few weeks. Now they've all come up a lot in the last few weeks, certainly, and the heavy snowfall will result in quite a bit of runoff this spring and likely above average runoff. And so that will further raise those reservoir levels. But since they did come from such a very low level, the rainfall and the upcoming snowmelt will likely get many of them back up to around normal, but not necessarily as high as what you might expect. Now, farther east in the Colorado River Basin, all the lakes are still running dramatically below average, still very, very low on Lake Mead and Lake Powell. We have had above average snowpack, though, so far this year across Colorado. And the chart at the bottom there shows that we do have, for the most part, everyone running 18 to 36% higher than average in terms of snowpack. And so we are going to see a better than usual water year on the Colorado River this year, and that will allow those lakes to come up somewhat. But again, they're coming from extremely low levels. And so even though we will see gains in water levels, we're not going to be seeing them get anywhere remotely close to normal based on the rainfall and snowfall we've seen so far. Now, looking at the wildfire outlook, not a whole lot of risk across the western U.S. with the wet pattern there. The risk across Texas and parts of the southeast is largely going to be confined here the next couple of months, where we do still have dormant vegetation. And anytime we see a strong wind event with the dry, dormant vegetation, we could still see wildfires in those areas. But then as everything greens up in the spring, given the conditions we've seen in terms of rainfall totals in many areas, the risk for wildfires during the middle and latter part of the spring season looks to be pretty low this year, unlike the last couple of years. Flood risks for the eastern half of the country at this point look to be limited mostly towards portions of the central and south central U.S., localized to areas that have seen the heavier rainfalls recently. And again, with wetter conditions forecast for the Ohio and Tennessee valleys going forward for the balance of the winter season into the spring, those areas will also be at risk for some river flooding as we head through the late winter and early spring periods. Now, looking at kind of a summary here for the balance of the winter season across the Northwest, again, increasing rainfall and snowfall as we head into February after kind of a drier January in those areas with heavier rain farther south. And so we should see a general uptick in snowfall in the mountains in those areas there, and staying for the most part colder than average for the next couple of months. The southwestern portion of the country likely seeing a drier trend after January especially, but certainly the rain so far will result in significant improvement in drought from what we've had over the last couple of years. And overall, a colder February, but trending warmer by April. The north central U.S. looks to be the main area across the eastern U.S. to have above average snowfall chances for the balance of the winter season. Again, a cold February likely, possibly milder March before one last round of colder weather returns during the month of April. The northeastern U.S., again, likely a split scenario there where the storm tracks will likely be from the Ohio Valley up towards the central Appalachians or eastern Great Lakes, and that will tend to favor snowfall and cold for the most part east of the Appalachians, and then the area along the coastal plains, likely for the most part seeing milder and rainy conditions with each storm, followed by brief periods of cold, but likely overall averaging warmer than normal. Again, I mentioned before the chances for heavier rainfall across the Tennessee and lower Mississippi Valley areas, and that will likely continue to be the case going forward here for the balance of the winter into the early spring. And also those areas will continue to see an increased risk for severe weather. As we progress towards the latter part of the forecast period towards April, we'll see the severe weather risk kind of shift from the southeastern U.S. more towards the lower Midwest and the southern half of the Plains region, and then expand northward from there as we progress beyond this forecast period. But generally speaking, a westward shift of the severe weather as we progress through the next few months. And Florida, for the most part, being the winner in terms of milder and nicer weather, with a warmer overall regime for Florida staying in place for the next few months. Now, looking north of the U.S. border across Canada, likely a very persistent colder than average regime for the central and western areas of Canada. The monthly maps you can see there on the right keep many areas of Western Canada colder than average right on through April. So not a whole lot of month-to-month variability. A wetter than average regime across British Columbia and parts of Alberta during the month of February, but then fairly seasonal rain and snowfall totals as we head into the spring season. As we look globally here, most of the cold focused here across North America as well as Greenland, and Europe and Asia overall looking to average warmer than average during the February to April period. But there is, again, that caveat of depending on how the polar vortex evolves during the latter part of January into February, if we do see a ridge of high pressure build right over the pole, fully displacing the polar vortex and weakening it, that would actually favor a colder than average regime developing for Europe. And that likely, though, wouldn't happen until the end of February or into March. But there is a risk, even though it may average warmer than normal for most of the next several weeks, and then likely again, as we head into April, there could be a window of time in that forecast, maybe end of February or March, where depending on how the polar vortex evolves, we could see a 2 or maybe a 3-week period where we do see colder than average temperatures across a large portion of Europe. And so it's still hard to say whether that will actually happen at this point. We'll have a better idea in a couple of weeks probably. But there is some risk, though, that even though it may be warmer than average for the bulk of the period, there could be a window of cold for much of Europe during the middle or so of this period. Now, looking at the renewable energy outlook in terms of wind and solar, we are looking to have a windier than average pattern across most of the plains. And so many of those areas are the highest wind farm concentration areas of the country. And so we should see higher than average wind generation production for the U.S. as a whole going forward for the next few months. In terms of solar, kind of scattered. The West Coast is a little mixed there. We should see a wetter than average pattern and more clouds than usual during February, but a drier trend there as we head to April. And obviously there's more hours of sunshine in April than there is in February too. And so that kind of skews things a little bit as well. But generally speaking, we may see a general increase in the amount of sunlight available along the West Coast by April, and kind of relatively close to average everywhere else. Again, wetter during the February-March time period, and a little bit drier and sunnier as we head into April. Key messages here to kind of summarize things. Again, return to cold for the central and western U.S. coming up here later this month into February. The East Coast likely still staying warmer than average, and potentially along the Gulf Coast as well. Snowfall risks are highest across the northern and northwestern U.S. during the next few months in terms of having the best chance for higher than usual snowfall. And then definitely very wet, likely across the Tennessee, lower Ohio Valley regions for the next couple of months. And severe weather is still a risk for the southeast going forward here for the next month or so, then gradually shifting westward more towards the southern half of the plains as we head into the month of April. Looking at the impacts on the energy sector, again, with the cold focused across the central and western areas of the country during February, that will be the primary area impacted in terms of higher heating demands. And given that the East Coast will likely, for the most part, average warmer than normal, the overall total U.S. impact on, for overall U.S. heating totals will likely still come in, at best near normal and probably still below average for the entire country as a whole. Again, the East Coast will likely see some short-lived, potentially briefly strong cold snaps, but more days than that will come in warmer than average along the East Coast. And for the most part, those warm periods will likely be more intense than the cold periods will be for the next couple of months. No major Arctic outbreaks on the horizon at this point, though, again, as Nate talked about with the polar vortex, depending on how that evolves here, there is that risk by later in February and March we could see a more meaningful, widespread Arctic outbreak if we do see the polar vortex evolve in a manner that would allow that to take place. So it's being batted around a lot right now, and there's the potential we could see a split of the polar vortex or other configuration that would allow us to turn very cold across even the eastern U.S. if it were to evolve the right way. So we'll have to watch that. That would happen, though, again, late in February into early March. So we'll be monitoring that in our upcoming seasonal outlooks for the next few weeks. And again, severe storm risk will be obviously more of a factor as we head into the later March and April time periods. Transportation, snowfall obviously being the main impact for that across the northern U.S. So above average snowfall really from the interior areas of the Northeast, kind of towards the Great Lakes, westward across the Great Lakes into the upper Midwest being the primary areas, and of course across most of the western U.S. The mountain areas likely seeing above average snowfall for the remainder of the winter season. Farther south, mostly an issue of heavy rainfall across the lower Ohio Valley, Tennessee Valley, down towards the Gulf Coast areas for the next few months. We likely will still see, though, some occasional periods of winter weather farther south, but certainly much more scattered than the northern part of the country. On the aviation side of things, Nate talked about our jet stream outlook earlier, and so kind of summarizing that again, the jet stream will be most active across the northern half of the U.S. during the next couple of months. Obviously, that will tend to shift northward with time as we progress into the early part of the spring season, but the Gulf Coast likely seeing lower than average jet stream level winds, and so that will be impacting flights across those areas. With the storm track being what it is from the south central U.S. up towards the eastern Great Lakes, we are going to be seeing certainly a lot of snow, low clouds, fog, that kind of thing across many areas of the north central, northeastern U.S. that will be keeping more frequent IFR conditions in place for those areas. And then again, as we progress into the early part of the spring season, the colder and potential risks for icing and snow and so forth will shift northwestward with time. And so across the northwestern U.S., that will continue to be a case, but we should see more warmth expand across the eastern U.S. as March progresses. And so we will likely see a reduction in the risks for that winter weather impact on aviation once we get past the early part of March. A brief preview here of our early summer outlook. This will likely change depending on how the evolution of La Nina and El Nino evolve during the next few months. But assuming that we do see La Nina finally weaken during the next few months and potentially transition towards a weak El Nino, likely seeing a cooler summer across the eastern half of the country than the last couple of years, but likely still coming in warmer than average across the western U.S. and potentially drier than average still across the south central U.S. As we head into this upcoming summer season. So that is a wrap of everything here. You can see the summary maps here for temperature, precip, and snowfall, but I'll pass things over to Nate, and he can walk us through any questions we've seen so far come through. Nate?
All right. Thank you, Steve. Thanks for wrapping that up. And we have some questions that have come in. First question is, do you think that the current La Nina pattern that is driving precipitation into California and away from the Pacific Northwest will continue in near term or even the medium term? I think I can take that one. The type of pattern that drove that, the atmospheric river pattern here was something that was actually not as typical of La Nina. Usually in La Nina types of winters, you have that, if you're going to aim the precipitation at the west coast, usually it's aimed further north towards the Pacific Northwest. But we had a little bit of an event that occurred that extended the jet stream so far across the Pacific Ocean and a little bit further south that it picked up a lot of moisture alongside it and then drove it up into the state. That pattern is going to be just about over now. So I think things are going to be a little bit more typical of La Nina, where more of the precipitation will probably be aimed more at the Pacific Northwest and not so much of extreme precipitation in California. So you'll be, the short answer is you'll be getting in on more of the action, I think, going forward. So that's the first question. The second question here. Well, we talked a little bit about the water situation in the West and the fire situation in the spring, but how do you think that plays out going forward through the summer season? Steve?
Yeah, I can go ahead and take that one. So it's kind of a mixed bag out there. We likely will still see a drier and well, it's going to be warmer than average across the western U.S. this summer based on our current forecast, and potentially drier along the west coast. But we could potentially see a more active monsoon season this summer if we do see a transition towards El Nino as the summer progresses. Typically, the monsoon rains really get going middle of July and especially during August into early September. And so that would primarily impact Colorado, Utah, Arizona, New Mexico, occasionally into far eastern California and Nevada. But so potentially they could see above average rainfall if that is the case as we progress through the middle and latter part of the summer season. So that would be a help there, kind of adding on to the rains of this winter season, but likely still drier and warmer than average across the immediate west coast. And one problem that you do have is when you do see a lot of rainfall in the winter season, you get more growth of everything during the spring, and then you have more fuel that can dry out and potentially burn the following fall. So we'll have to watch conditions out there as we progress through the rest of the winter into the spring. The abundant rain is likely going to cause a lot of extra growth this year compared to last year. And so if we do actually end up dry across much of the West this summer, that could potentially actually increase fire risks as we head into the, especially the upcoming fall season, since everything will likely be quite dry by that point in time.
Awesome. Thank you, Steve. Very good points there. But despite all the wetness, fire can still be a thing in the summer out there, even during a wetter winter season. So definitely something to watch. Next one here, a little bit more clarification on the polar vortex. We're predicting weaker or a split. I'm not 100%. I'll take that one. I'm not 100% sure which way this one's going to go. You notice when I saw that spaghetti, the plots there, where it looked like the third grader drew it. That means there's a lot of uncertainty here going forward over the next couple of weeks. So I think it'll stay just weaker and not split. I believe that's the direction we're headed, where it's just displaced. So I think that kind of reduces the risk of it bringing a major cold into the United States, but I'm not quite sure yet. But either way, if this were to occur, the time to watch would be the very end of February and during the early period of March. There could be a period in there that the cold could come down if it does indeed line up like it did earlier this year. So a lot of uncertainty going forward, something to watch. Definitely want to keep it in mind, but right now we're not imminently going in that direction. All right, got another one here. Do we expect ice storms to be a significant threat during the late winter season? You want to get in on this one, Jeff?
Sure, yeah, I can try to answer that. Yeah, the worst ice storms tend to occur, or the ones that are more longer duration and significant tend to be down more in the Oklahoma, Arkansas, Tennessee Valley area. And those are probably more common during El Nino winters when there's more cold air that does penetrate down on a more frequent basis. So thinking the chances of a really bad one are probably a little bit less risk than normal for that area. Another secondary area that tends to get a lot of ice storms is more the northeast part of the country, Pennsylvania, southern New England region, northern Appalachians, and due to the generally mild conditions expected here over the next couple of months, I think probably a little bit less than average risk in that area as well. One probably a third area that tends to get the nastier ice storms that are more significant is in the southern Appalachians region, the Western Carolinas. Um, and again, that area probably a little bit lower risk due to the generally mild conditions overall. So when you look at the balance of things, I think probably all areas a little bit less risk than an average winter. But again, as we always have to preface, all it takes is one individual storm to come through with the ingredients coming together just right, and you can have a nasty event. But at least statistically, we're probably looking at a little bit less risk for ice storms than normal. You tend to get a lot of lighter freezing drizzle and light freezing rain events that can occur in the upper Midwest region and into the Great Lakes. So those are more of a travel impact hazard, slippery roads, as opposed to the real heavy accumulations of ice that are more of a power outage issue with power lines and trees coming down. So um, can't really say that the risk of those really weak events is going to be less in the Midwest region than in the Western Great Lakes, but at least those are less of a major catastrophic type impact.
Well, that makes sense. Thank you very much, Jeff. All right, I think we've gotten to 5 past the hour here, so I don't see any more questions.
There is one more question right there. I can read that one.
Oops, I missed
It
it.
asks, this will be the last one. I read the Arctic was extremely cold at the beginning of winter. Is it still abnormally cold now? I can briefly just answer that. No. We did have a lot of Arctic air in place at the surface during the early part of the winter season. That's what came down in December. That has since modified. So things are not abnormally cold at the surface. We did still have a lot of abnormally cold air in the stratosphere with the polar vortex. That is also moderating currently as the polar vortex weakens. So that's kind of the way things have been trending over the near term. But there's no unusually cold air for this time of the year across northern Canada or the Arctic that is, kind of poised to spill down into the U.S. here during the next few weeks.
Thank you, Steve. Are there any other questions that came in that I missed?
That's the last one I saw.
All right, well, pass it back to Andrea here. She can close the webinar for us.
Thanks, Nate. And thank you everyone for joining today. Like I said in the beginning, we will send out the recording of this webinar in about a week. So look for that. And if you want to forward it on to any of your colleagues who weren't able to attend, you can do so at that time. Thank you. Have a great day. And you are now free to disconnect.